Hello students, this is Dr. Saurabh Sir's class. We are Dr. Saurabh Sir's classes team and we are going to organize a batch that will help you for the TIFR, NBHM and ISI-CMI, this kind of exams. And this is our contact number which is seen in the screen, and the number is 98367930076. Again I am repeating it, 98367930076. Please call on to this number and you can enjoy all the opportunities that will help you for your examinations from our Dr. Saurabh Sir's classes. So we are now solving the TIFR GS 2025 questions. So this question is on the rank of a matrix, and the question is telling us that let A be a non-zero n cross n matrix with real entries where our n is greater than 1. Consider the following statements. If our a square is equals to 0, then rank of A is less than equals to the greatest integer near n by 2. Okay, and if our rank of A is less than equals to n by 2, then A square is equals to 0. The converse statement of statement 1. So now which of the following statement is correct? Our option A is telling us that 1 and 2 both are true. And option B is telling us that 1 and 2 both are false. Option C is telling us that 1 is true and 2 is false. And option D is telling us that 2 is true and 1 is false. So what can be done with this question? So we have to recall some important concepts about the matrix rank and nullity. As we know that the rank of A, that means this rank of A is the dimension of the column space of A, and the nullity of A is the dimension of the null space of A. And we all know that the rank nullity theorem for an n cross n matrix is what? That is R of A plus N of A is equals to N. Okay. So the nilpotent matrix, now we are going to discuss something about our nilpotent matrix. So a matrix A is called nilpotent when then our if our a to the power k is equals to 0 for some k greater than equals to 1. Okay, so now if our a square is equals to 0, then A is a nilpotent matrix of index 2, meaning A is not equals to 0, but our A square is equals to 0. So now we are discussing the important property of nilpotent matrices. For an n cross n, for an n cross n nilpotent matrix A, our rank of A, that means the R of A, rank of A is less than equals to n by 2, or the greatest integer corresponding to n by 2. This is because the Jordan form of A consists of Jordan blocks of size at most 2, and hence at most half of the rows and columns can contribute to the rank. Okay, now we are going to analyze the statement 1. They told us that if our a square is equals to 0, then rank of A is less than equals to the greatest integer function near n by 2. Okay. So as noted above, if our a square is equals to 0, then A is a nilpotent matrix of index 2. The Jordan form of A will consist of Jordan blocks of size at most 2, and therefore the matrix of A is at most the total number of Jordan blocks, which is at most our this. Yeah. So our statement 1 is a correct statement. We can easily see that. Sorry, I am wrong here. Our statement 1 is correct. Yeah. And we have to think about our statement 2. Okay, so now we are going to analyze our statement 2, that is telling us the rank of A is less than equals to the greatest integer near n by 2, then A square is equals to 0. Okay, so this statement is false because the condition rank of A, rank of A less than equals to the greatest integer near n by 2 does not necessarily imply does not necessarily imply A square equals to 0, because for an example we can say that if our A be this, then what will happen? Then we can easily say that the rank of A is 1, and it is satisfying that rank of A is less than equals to n by 2. Our n is 3 here, so we can write it 3, so that will be 1. And our A square is not equals to 0, because our A square is equals to A, we can easily see that. So our statement 2 will be false. Where is my this? Okay. So our statement 2 will be false. So the correct option of this, so our option A will be cancelled out, option B will also be cancelled out, and our correct option of this question is my option C, and our D will be cancelled out. So hope you understood, guys. Thank you. And I am telling that if you have any queries about mathematics or this or on any other kinds, so you can call on this number and feel free to do that, and please contact in this number, and our team will help you with your doubts and by one-on-one session and all the batches and etc. Hope you are doing well, and thank you guys.